Morning everybody, welcome to Monday morning here, and well, let's hope we can have some continued success from last Friday's successful capacitor removal. But today we have an A1990 and it's shutting down and kernel faulting, which is gonna be a difficult one usually. These sort of faults where it's not complete death and it's all wishy-washy, they sometimes can be things like PCH failure or some sort of weak RAM or things like that. It may not necessarily be a electronics board fault per se, as opposed to internal in the electronics. Anyway, we'll get this one apart and have a look. If I can't find it quickly enough, we may just have to move on from this one. Being an A1990, it's slightly getting to the old age status, but it's still a very good machine, so let's see if we can get this one running. Alright, we've got a battery replacement here, so very first thing I'm going to think of is the battery just isn't keeping up with its task. They didn't specify whether the collapsing was happening while it was on charge or while it was just freestanding. If it's just a case where it collapses while freestanding, like as in running off its own battery power, then I'm going to blame the battery pack pretty much straight away. Now I have to... Oh, what the... Alright, I'm pretty sure we found the fault. Have a look at this. So this here is the data cable that comes from the battery to the board. And you need this data cable to have a good connection, because as soon as that wiggles out or anything like that, the battery effectively is disconnected from the machine. Or at least it makes the machine shut itself down because it thinks, oh no, I can't talk to the battery anymore. So that alone could well cause it. So all we have to do, flick that down. It is a bit of a sloppy fit though. Look at that. Let's take it out and have a look, see if there's any damage. It seems okay. It looks like it got ripped out at one point. See how there's grooves up here? These are on the lock sections. Overall feels like a bit of damage there, but yeah, I'm thinking without that locking tab being down, it would have been intermittent at best. Alright, we have a situation here where it looks like the battery has no charge in it, so now we've got to see whether this battery is going to charge or not. So what we're going to do is we're going to watch this number here, this 319. Now this represents the lowest current value within the window of the graph that you can see. And in a extreme trickle charge situation, we should hopefully see, oh there we go, it's charging now. And we've got our beautiful staircase happening here. This is the sort of charge pattern that you want to see. In this particular situation, I'll now just have to go and... Oh, what happened there? Gave itself a reset. Still staircasing again though. This does sometimes happen, I've noticed. I don't know why. But it will get to a couple of amps and then drop reset and then start up again. So let's see if it does that again. At this point I essentially need to go back to the customer, in this case the business, and say, when was this battery replaced? Was the fault happening before or after the battery was replaced? If it was happening after the battery replaced, then I'd say it's probably the lock tab. If it was happening before the battery was replaced, then we've got something else we have to look for. That's interesting. It hits 2.9 amps, 3 amps, and it resets. That's weird. We need more history on this one. Alright, this thing keeps cycling once it hits around about 3 amps. So what we're going to do is we're going to take the logic board out, and then we're going to put that into another chassis, and then that way we can determine whether we've got a problem on the board or whether we've got a problem in the battery. Before I put in another case, I'm just going to have a look over the board anyway. That's pretty bad. That definitely needs replacing, so probably a good thing we found that one. That there's a classic 2B5. In fact, that is actually shorted, that cap, but it has disconnected itself from the board. Okay, that diode has actually been knocked off the board at some point. Probably on a prior removal is my guess. It's not critical, but it does need to be replaced. We're going to do this in a way of it being like 2 steps forward, 1 step back. We need to eliminate this damage here before we do any further testing, because it's quite possible this is like the last breath of success that the machine has before it dies and takes its data. So we'll eliminate this damage, then we can put in another chassis and see if it behaves. If it behaves in the other chassis, then we'll bring it back to this original chassis and see if it still behaves. So regardless of whether the battery's at fault or not, this damage has to be repaired. To say this person was lucky is a bit of an understatement. That could very easily have ended up making them lose the data. What usually happens with this particular fault is that the capacitor will corrode, but it will still keep operating, but it gets hotter and hotter, and it starts carbonizing the board. It starts burning the fiberglass and resin, or rather just the resin, through the board. And on the other side of this board is the voltage regulator that manages the power to the NAND chips. And when that gets damaged, then the voltage is not correctly regulated, and that's when it goes and destroys the data. We're also going to replace a couple of these. Might take the whole 3 there. These are on the NAND regulated side, the 2.5 volts. This one is the main PP bus. So it's okay if this one shorts, we can recover from that. But the damage that this one causes when it corrodes through the board and carbonizes the board, that's the problem that this one causes. If these ones short, what the problem can be is they might damage the regulator just by overcurrenting it. And then when people just replace these after they've shorted and power up again, that damaged regulator then destroys the NAND chips. There's been a few machines I've had come in where they've done the cap replacements, but they didn't replace the regulator after these have been shorted, and it unfortunately ends badly. We need to clean up all this corrosion too. It's looking healthier already. This test pad is actually now disconnected from the rail, but that's okay. In this particular case, it's only a test pad, so it's not a problem. We'll just leave it disconnected. Small amount of flux. Do the same for these. Just going to tin up these pads with some leaded solder. Will make it easy to bring in the new ones. And we clean up the flux, the excess. So this one here is a 10 microfarad 25 volt. These here are 20 microfarad 10 volt. A little bit more flux again. Ooh, that's way too much. One replacement capacitor. The heat shield protection there is actually just to prevent the sticker from getting too burnt. Alright, got a little bit of oddity here. These two are actually resting on their sides. This one here is on the upright. It doesn't actually really matter in this situation, so we're not going to mess around. Just leave it as it is. It's good enough, really. It really is good enough. These are not high frequency rails that they're dealing with or anything like that. You know, the difference in impedance and frequency response by having it on its side versus upright is, for all intents and purposes, negligible in this situation. Most of the time you wouldn't even know if your cap was on sideways or otherwise, because most of the time they have a square cross section or close enough. These ones just happen to have a slightly wider cross section. Fortunately, it's not an issue either, because the pads are separated enough that it's easily fitting them. In spite of the wonkiness, I am happy with that. We now at least do not have a situation that may bring the whole machine down. That there is our voltage regulator for the NAND. As you can see, it's directly on the other side of these parts, and the corrosion, or rather I should say the burn through from the carbonization, usually happens around under here, and that's why it destroys the regulation, which then destroys the chip. Okay, so this is my test chassis for the A1990s. It's a known working one, so we're going to put this in and see if the charge behavior is any different. Alright, so let's see how we go with the test unit. Okay, so we're stepping up in the current, which means it's probably trying to charge it. I'm just going to close the lid to simulate the same situation where it was asleep, but the charge kept resetting. Okay, so we have our staircase starting. The test is going to be when it gets to around about the 3 amp stage, does it reset? The other possibility is that it's not so much how much current was going through, but how long it had been charging. Interestingly, we've got a top out here, so there's obviously a reasonable amount of charge in this battery pack already, and it's hit 2.5 amps, and it's saying I'm not going to charge at any rate faster than that. Around about this sort of time is when we would have hit 3 amps previously. I think we can safely say it's not doing the reset anymore. This also eliminates the battery data flex cable from the list of suspects. Alright, I think we can say that it is functioning fine as it is. If we put it into the original machine and it fails again, then we know it's a battery fault. Just realised we have to fix up that protection diode. It doesn't look like much, but yeah, that's definitely knocked off. You can just tell by the angle. Even though these diodes are so small that they tilt off on their pads, no matter how small you make the solder pad, you can just see that it was just too much. In this particular case, I think we can safely knock you off. Nope. Alright, I've created myself a problem here. Okay, fortunately we have a nub there, but that was my mistake. I assumed that I'd be able to knock that off, and I was not able to. It definitely had been knocked physically for the first bit here, because it took the pad clean out of the actual diode. So I made a mistake there. I should have just hot aired that off. Fortunately, there's enough of a nub there that I can put a little bit of a solder ball on, and it'll be fine. First thing we do is get rid of the old pad that was left behind by the diode. There we are, I've got a little nub there of solder. That's pretty much all we need. Just trying to remove the excess solder from this pad. Okay. Once again, trying to avoid melting the little protective stickers. Okay, so we can see the band on the diode is towards the shield. Just put that there. Get ourselves a tiny amount of flux. There you go, it's a lot more than a tiny amount, but that'll do. Alright, that's soldered on. See, it's not moving when I touch it. At the risk of ruining things for the sake of perfection, I'm gonna just add a smidge of solder paste in that area. So we've got about a dozen balls there. That should hopefully do the trick. That's what I wanted. So that's been drawn in underneath that pad and then given a little bit more grip for the pad overall. Right, again we're going to start lid closed, just plug in the charge, see what happens. Okay, so we have our staircase starting. We're almost there. Fingers crossed it goes fine. 2.4. Alright. Interesting to note, the fans didn't spin up this time either, so I do wonder actually whether that capacitor was the fault, in the sense that maybe it was shorted sort of just enough to put a unexpected load on the board, but not enough to shut the board down under normal circumstances. And it wasn't until that the machine started really demanding more, like over 3 amps, that the cumulative demand became too much and the machine shut down. That looks pretty good to me, and I'm happy with that result because A, we save the data, B, it doesn't need a battery replacement. That's all I got. Let's open up the lid and see what happens. I'm going to guess it won't shut down this time if I pull the battery, although it's not showing any charge now on here, so we'll give it a couple of minutes and then we'll do the test with removing the connector. Alright, it's been about half an hour now. I've been charging it with the lid closed to try and get the battery voltage back up, or battery charge back up. I've just now opened it up, as you can see, and it's ramped up to this 4.157 amps. And it seems to be holding steady, so I think, yeah, the problem was actually that corrosion on the board, and the capacitor must have been shorted just enough to create an extra leakage on the board that it wasn't prepared to handle. It might have been pushing the overall current draw through the system to be excessive for what I was expecting. Okay, so we got another nicely repaired A1990. This one thankfully was found before it was too late and the data was lost. We have a little bit of uncertainty here as to the real cause of the fault here, but I think that it's most likely it was the capacitor, and unfortunately once those capacitors crack like that, then they're very sensitive to physical changes causing their resistance to change because of all the cracks in it, causing the plates to contact or not contact. So I think in this case it was a good example of why, for things like the A1990, the A2141s, you really should take the board out and inspect it before powering it up. Now, I didn't follow that this time around. I just powered it up and to have a look at its behavior, because the docket that came in said that it was booting and then shutting down. Just for the sake of safety of the data, it's always a good idea to just take the board out, have a look. It's extra time, but it may save the data. We were lucky in this case. We managed to get it fixed before any damage was done. But there could be another scenario where we power it up and that was the last time it was willing to do that before it decided to take out the whole board. So that's a bit of an error on my part there. A little bit of trying to jump the gun perhaps, or a little bit of laziness perhaps. We also saw that I did damage to this board this time around. I was trying to get that diode off the, it's an input protection diode. off the board, and I just thought I'd be able to knock it off, but it didn't work out that way. It actually took the pad with it. Thankfully, we were able to make a repair. If we had not been able to make a repair, then that would have been on me. So there's and it's all on video, so I wouldn't have been able to deny it. Alright, well, that's everything for today. Thank you very much for watching. I hope you all have successful repairs on your end, and I'll catch you in the next video, whenever that may be. Until then, you'll take care. I'll see you later.